Hi, let's look at the system Verilog repetition operators. There are three types. One of them is consecutive repetition operator, represented as star. And then there is a goto repetition operator, represented as a dash arrow sign. And then there's a non-consecutive repetition operator as equal to. Today we'll be discussing goto and non-consecutive repetition operators. Looking at a goto repetition operator, we use it for defining the properties for system Verilog assertions. Goto operator can be one value of n, or it could be range of values m to n. That is, some expression will be repeated n times, or anywhere between the ranges of m to n. So what goto repetition operator is, it allows a Boolean expression. And remember, this is a Boolean expression and not a sequence operation expression. So this Boolean expression can be repeated for n times in consecutive or non-consecutive cycles. What that means is, let's say a expression A is asserted, it can be remain asserted for two clocks consecutively, or there could be two repetitions of A separated by any number of cycles in between. Let's take an example where A is repeated two times, followed by immediately B to be true. So in this goto assertion property, A occurs two times, and those two times can be consecutive two cycles, or it could be separated by any amount of cycles. And it is immediately followed by B becoming true. Let's look at a little bit more complex example where you have implication operator, where you have a non-overlapping implication. So you will look at the precedent of this implication where when A becomes true, then then the assertion will be triggered or property will be triggered, and then you will look for consequent to be true as well, right? In this consequent, what you're looking for is that B is repeated two times, and immediately for after the second assertion of B, C has to become true as well. So let's look at it from the waveforms perspective, that you have the clocks. At some point, A gets asserted, and uh, then you start looking for B in the next cycle, as implication operator says. So anytime after this trigger, B can come. So you look for the first assertion of B, and then you look for the second occurrence of B, and there could be any number of clocks in between. And then as soon as B occurs in the next clock, you want to have C asserted. So if these conditions are met, then this property is true. Let's look for a filling scenario that A occurs, A is true. After we start evaluating on this edge of the clock, and after some time, B occurs, and then we look for the second occurrence of B, and then after that, C occurs one clock cycle later. So in this case, since the C did not occur immediately after second occurrence of B, this property will fail. Let's look at a consequent with 5 cycle delays in between, and between antecedent and consequent. So any changes to B and C are ignored for 5 clocks. And then you start checking for B after the 5th cycle. So let's look at this expression where you have a implication operator. This time we are using a overlapping operator. That means you will start looking for B, or the um, uh, consequent immediately in the same cycle as A has occurred. So you start counting the clocks when the A has occurred. 5 clocks later, you look for the same expression as we looked before. So first you will look for two occurrences of B, and then you will wait for C to occur immediately after the second occurrence of B. We'll look for additional examples in later slides. So let's go to the non-consecutive implication also. So the difference here is that for non-consecutive, you're represented as equal to n, or a range m to n. So the difference here is that this operator also looks for non-consecutive occurrence of A here, but the B doesn't have to occur immediately in the next clock. So what this property says is that A could be false for any number of clocks before B is true. Or other way of saying that is B doesn't have to occur in the next clock immediately after A. So let's look at the expression here, like where again you have a precedent A. When A becomes true, you look for a based on this non-overlapping operator, you look for the next clock, and then you start evaluating the right hand side. And the right hand side, there will be two occurrences of B, and then a occurrence of C, just like the previous example we looked at. The only difference is that the C doesn't have to occur right on the next clock after the second occurrence of B. So let's look at the passing and failing case here as well. In the passing case, A is true. In the very next clock, B becomes true. Then you wait for the second occurrence of the B, so which happens after 1, 2, 3, 4 clocks. And then after that, C occurs. So C is not happening in the immediately next clock, but there's a clock in between. So in this case, it is passing. And if you may remember the goto operator, this scenario was filling in when we were using the goto operator. Let's look at a failing case here. So failing case, B occurs after A. So the property has been triggered, and you wait for the second occurrence of B. So far, so good. Now you are waiting for C. So instead of C happening, B happens again. So if that happens, this fails the property. So this is a failing example. So now let's look at few more examples. And I've created 6 cases here: C0, C1, C2, C3, C4, C5, C6. So in these cases, let me describe what is happening. So there are 3 variables being defined: A, B, and C. In the first case, A is going true. In the same cycle, B is also going true. And then there is a B here followed with C. In the second case, we are permutating across various conditions when A and B occur. In the second case, instead of B happening in the same clock, it's happening in the next clock. In the third case, there is 2 clocks delay between A and B. And the next case, there is a clock delay between second occurrence of B and C, and so on. So there are various combinations being defined in various cases, and we'll look at them one by one. Now, in terms of the syntax, there are various goto uh, uh, and equal to 2 operators are being looked at. So let's solve them one by one. In the first scenario, you have A implicit 1 clock later. You evaluate this expression where B has to occur 2 times followed with C. So in this first case, A is occurring, so that means the property is being triggered. Since there is a _1, you want to wait for 1 clock after this occurrence. So this will be a first clock, and in this clock, then you look for first occurrence of B and second occurrence of B. So after that, in between there is a C occurrence. So this expression will fail. Let's look at the second case where A is occurring, followed with 1 clock later, B occurs for 2 times. And then immediately after second occurrence of B, C is happening. So this is a passing case. Let's look at the third example where A occurs. So your event is triggered here. So you look for 2 occurrences of B, they happen. And immediately after that, C is happening. So this is a passing case. Third scenario where A occurred, followed with 2 occurrences of B, but C did not occur in 1 clock because your property is asking for C to happen immediately in the next clock. So this will be a failing case. Next case, A occurs, the event is triggered. Then you wait for 2 occurrences of B that happened. Then according to property, C should have happened. Instead of that, another occurrence of B is happening. So this property will fail. In the next incidence, 3 occurrences of B happen, and immediately this property will fail. And then in the final scenario, where you have A occurring and C happens, but much later, so this scenario will also fail. Now let's look at the non-consecutive repetition, where you are repeating 2 times non-consecutively. So in the first scenario, again, because there is a 1 clock delay expected, so this property will fail. This property will pass because C can occur any number of clocks after the second occurrence of B. This occurrence will also pass, just like the previous goto operator case. Now let's look at this scenario where A occurred. So property is triggered. You look for 2 occurrences of B, that also happened. C is also happening, but it is happening after 2 clocks. So in the previous case of goto, it was failing, but in case of non-consecutive, it will pass. Let's look at the next scenario. There are 3 occurrences of B, so this will be a failing condition. There are 3 occurrences of B here in this condition as well. So this will also fail. And in the last case where you have A occurring, 2 occurrences of B followed by at some time later occurrence of C. So this will be a passing case. Let's look at the third example here. Like here we have a non-overlapping or rather overlapping implicit operation. On the left-hand side, you are evaluating A, and on the right-hand side, you are evaluating this expression, but there is no clocks in between. So that what that means is that this expression can be start to get evaluated in the same cycle as A occurs. So let's look at the cases again. So going with A triggers this expression. So according to the implicit operation, you are looking in the same cycle, you start to evaluate B. So B occurs, there is a second occurrence of B and followed by C, which happens in the very next clock cycle. So this condition which was failing before will pass in this expression. Now let's look at next scenario where B has been shifted by 1 clock, which is fine because you have met the condition where consequent can occur any number of clocks starting with A. So this expression will also pass. Similarly, in this scenario, B is occurring after 1, 2, 3 clocks, but this is still valid scenario because 2 occurrences of B followed by C is a passing scenario. So this property will also pass. Now, what happens here is that C is occurring, but 1 clock later. So just like previous goto property, this will fail. And we can follow the similarly other scenarios in goto operator. All these are failing conditions. Now let's look at in the same scenario where we have removed the delay for B, but we are using a non-consecutive repetition operator here. So in this scenario, just like where so A occurs, so A triggers the check, and then you're looking for B to occur 2 times, which happens, and C can happen anytime after second occurrence of B. So this is a passing condition. Just like the previous non-consecutive operator condition, this will also be a passing condition. And we can just follow along like where just like previous conditions we discussed, this is a passing condition. Now let's look at the failing conditions, like where previously in the non-consecutive it was a failing condition, but because C can occur any number of clocks after second assertion of B in case of non-consecutive, so this will become a passing condition. In this case, there's a third occurrence of B occurs before C, so this will remain a failing condition. Similarly, there's no occurrence of C in this scenario, so this is a failing condition. Again, and lastly, in C6, this will become a passing condition. So as you can see that for minor changes, some expression can pass or fail, right? We'll look at some more examples for exercise. Now, we'll look at a non-overlapping operator. In the previous examples, we looked at overlapping implicit operation. Here we are looking for non-overlapping, right? The only difference is when you start evaluating the expression in the same clock cycle or the next. So let us look at these examples. These expressions are very similar to the previous ones we discussed. So it should be pretty straightforward to solve these for this time onwards. So in the first expression, you're looking for A, and in the next cycle, you start to evaluate the right-hand expression. So you will ignore, so A triggers this property, but you will ignore this first B, which is occurring in the same cycle because you want to start evaluating the right-hand side on the next clock, which happens to be this clock. So starting this, like you will look for 2 occurrences of B. So yes, before the second occurrence of B occurs, there is a occurrence of C. So this property will fail here. Let's look at the second case. A occurs, which triggers the property. In the next clock, you look for 2 occurrences of B, followed immediately with occurrence of C. So this is a passing case. Now let's look at the C2. Case 2. In this case, A occurs, so it triggers. Then there are 2 occurrences of B, which is good, and then immediately the C is happening. So it is a passing condition. Now C3, you are evaluating A. In the next clock, you start to look for 2 occurrences of B, which happens, and then C. So this is a so this is a failing condition because why it's failing is because C did not occur in the very next clock, right? C4. So before C is happening, there are third occurrence of B. So this will be a failing condition. Similarly, there are three occurrences of B without any C. So this is a failing condition. Now in this scenario, C is occurring, but there is a clock delay in between. So this will be a failing condition because here you have a goto property. Now, if you replace the goto with non-consecutive, pretty much everything will remain the same except the last one, where these two failing scenarios where C is occurring, they will pass, and other behavior remains pretty much the same. And we can walk through the exercises. Like, let's just look at the first one where you start to evaluate B here, but before second occurrence of B, there is a C, so it's a failing condition. And just like the previous example, this will be passing condition. Now, let's come to a place where we are removing the delays in the right-hand side and the implicit operator. So if we remove that, then there is no change in behavior of this particular thing because now we are starting to evaluate the right-hand side after the first clock edge. So this will remain the failing condition. In the previous page, we looked at if we had used a non-overlapping implicit implication, then this will become a passing condition. But in this case, it remains failing. Other properties, like, they are pretty much similar to the first one. So there will be two passing cases here. Let's look at this failing case. This remains a failing case because of the C. So this remains failing, and all of the other properties will follow the first row here, and they keep failing, right? And then let's look at the last one where you have non-repeating. So this property remains failing because you're evaluating on the next clock, and there's no change in the properties here. And other, just like the second row, they'll remain passing because you're evaluating on the next clock, and next clock this is high, and this remains a passing condition. And then this C3, which was failing before, will pass in this case because there is no C can occur any number of clocks after the second occurrence of B. And then you have failing condition because there is no C here, and this is a passing condition because C happens and it can happen any number of clocks after the C. So these two pages cover several examples, and I will take one more complex example where I'm increasing the delay in my right-hand side. Like, so what happens instead of 1 clock or 0 clocks, I'm waiting for 5 clocks now. So what this means is, and I'm using a non-overlapping implication. So what will happen in the first case is A occurs, so B is occurring, but I have to ignore it because I have to wait for 5 clocks before the first accession of A. So we look for 1, 2, 3, 4, 5th clock. So this is the first time I will start to look for A. A is 0 here. So I'll ignore all of these discussions which are happening between A and B and C. So the first occurrence is here, and second occurrence is here, followed with C. So suddenly this expression becomes passing in this case. So this is very interesting use case. So please pay close attention to this. And in the previous pages, we saw this condition failing, but now it is passing because of this weird timing relationships which help this condition to pass. Let's look at the C1. C1, again, we look at A. So the accession gets looked at. So we are looking for 5 clocks. Anything which is happening in between, we'll ignore. So 1, 2, 3, 4, 5 clocks. So in the 5th clock, we see that C is being asserted. So this is immediately failing. There's no B. And same thing we do for next one, where we look for A triggers it, and then we look for 5 clocks, 1, 2, 3, 4, 5. In the 5th clock, the first accession of is B is here, but there is no second accession, so this will be a failing condition. Let's look at the next one. 1, 2, 3, 4, 5. So this is the first accession followed with C. So this is a failing condition. In this, you look for 1, 2, 3, 4, 5. So this is my first occurrence. This is second occurrence followed with C. So suddenly this becomes my passing condition. And next occurrence, there's no C, so this will fail. And the next occurrence, now let's look at 5 clocks. 1, 2, or sorry, 1, 2, 3, 4, 5. So there's the first occurrence of B followed with first occurrence of C. So this will be a failing condition. So this is a very interesting scenario. For the same cases, you can compare it to the previous pages, and you will find that these are interesting scenario being created because of just delaying the evaluation by 5 clocks. Now, the same thing where we do the same thing. I think this should have been equal to sign here instead of goto operator. So in this case, we will be only difference will be we'll evaluate C at a different clock. So any failing conditions where C was delayed by a clock, which is here, it will flip. So this will become my passing condition. Now let's look at it. Sorry, like before I say that. So 1 clock, 2 clock, 3 clock, 4 clock, 5 clocks. So this is the first occurrence of B followed with C. So this will remain failing. So this does not pass. This will remain a failing condition. And other conditions, they hold true. So this will remain passing. This condition will fail because there is no C, and this condition will fail because there is no 2 occurrences of B. So this is a special scenario which I wanted to cover. With this, I will conclude this chapter.